Okay, here we're going to solve exponential and logarithmic equations. So we're going to start with exponential equations. One thing to understand is that an exponential function is considered a function that has a variable in the exponent position, okay? So this is an exponential function here. We have 2 to the x is equal, an exponential equation. We have 2 to the x equals 4. So what we're going to do is we're going to rewrite both sides so that they have the same base. So we can make both of the bases look the same. That will allow us to apply the rule which states b to the m equals b to the n, then m would equal n, okay? So I can rewrite 4 as a base 2 to a second power. By doing that, I automatically can assume that x equals 2, and that's it. Okay? And you can always plug it in so that you can check it. Okay, let's look at this one. Alright, here we have base 4 to the 3x minus 1 equals 64. Well, we can make these bases look the same. 4 is 3x to the 3x minus 1. 64 can be rewritten with a base 4 and exponent 3. So using the rule, we will just set the exponents equal to each other, and then we solve for x. 3x equals 4, x equals 4 over 3. And that would be the answers. Now, we cannot always apply that rule when we are trying to solve logarithmic equations. So, for example, we have 5 to the x is equal to 17. I can never make 5 and 17 have the same base. So what we're going to do, we have never solved anything where we had to solve for the exponent, okay? So what we need to do is we need to get the exponent down, okay? And so we use the natural log rule. When we do that, it's going to allow us to expand the problem so that we can get the exponent to come down, okay? So, for example, there's a rule. We have natural log of b to the x. It would be equal x to the natural log of b. So see, the exponent comes down in front. That's your power rule. So here, I bring my natural log in, and whatever we do on one side, we must do to the other. So here we have x times the natural log of 5 is equal to natural log of 17. Well, we are trying to isolate the x, so we are going to divide both sides by 5. So we get x equals natural log 17 over natural log of 5. That is called our exact answer. That is the answer, okay? You're then going to put that in the calculator so that you can identify what the approximate answer is. And we're just going to round to 2 decimal places, so 1.76, okay? And that's how you would work that problem. Let's say we have e to the x equals 15. So to bring down that x, we're going to bring in the natural log on both sides. I automatically bring my exponent down when I bring in the natural log. Alright, and so from there, I don't have to divide by anything because natural log and e automatically cancels out because they're 1. Remember, they equal 1. So my answer is x equals the natural log of 15. And then you want to simplify that in terms of getting the approximate answer. So you just calculate it and it comes to 2.71. Okay? And so that's how you solve exponential equations using those two forms.